In this chapter, we're going to be taking a deep dive into agents with the LangChain, and we're going to be covering what an agent is. We're going to talk a little bit conceptually about agents, the React agent, and the type of agent that we're going to be building. And then based on that knowledge, we are actually going to build out our own agent execution logic, which we refer to as the Agent Executor. So in comparison to the previous video on agents in LangChain, which is more of an introduction, this is far more detailed. We'll be getting into the weeds a lot more with both what agents are and also agents within LangChain. Now, when we talk about agents, a significant part of the agent is actually relatively simple code logic that iteratively runs LLM calls and processes their outputs, potentially running or executing tools. The exact logic for each approach to building an agent will actually vary pretty significantly, but we'll focus on one of those, which is the React agent. Now, React is a very common pattern, and although being relatively old now, most of the tool agents that we see used by OpenAI and essentially every LLM company, they all use a very similar pattern. Now, the React agent follows a pattern like this. Okay, so we would have our user input up here. Okay, so our input here is a question, right? Aside from the Apple Remote, what other device can control the program Apple Remote was originally designed to interact with? Now, probably most LLMs would actually be able to answer this directly now. This is from the paper, which was a few years back. Now, in this scenario, assuming our LLM didn't already know the answer, there are multiple steps that an LLM or an agent might take in order to find out the answer. Okay, so the first of those is we say, our question here is, what other device can control the program Apple Remote was originally designed to interact with? So the first thing is, okay, what was the program that the Apple Remote was originally designed to interact with? That's the first question we have here. So what we do is I need to search Apple Remote and find a program it was used for. This is a reasoning step. So the LLM is reasoning about what it needs to do. I need to search for that and find a program it was used for. So we are taking an action. This is a tool call here. Okay, so we're going to use the search tool and our query will be Apple Remote. And the observation is the response we get from executing that tool. Okay, so the response here would be the Apple Remote is designed to control the front row immediate center. So now we know the program Apple Remote was originally designed to interact with. Now we're going to go through another iteration. Okay, so this is one iteration of our reasoning, action, and observation. So when we're talking about React here, although again, this sort of pattern is very common across many agents, when we're talking about React, the name actually is reasoning, or the first two characters of reasoning, followed by action. Okay, so that's where the React comes from. So this is one of our React agent loops or iterations. We're going to go and do another one. So the next step, we have this information. The LLM is now provided with this information. Now what we want to do is search for front row. Okay, so we do that. This is the reasoning step. We perform the action, search front row. Okay, tool, search, query, front row. Observation, this is the response. Front row is controlled by an Apple Remote or keyboard function keys. All right, cool. So we know keyboard function keys are the other device that we were asking about up here. So now we have all the information we need. We can provide an answer to our user. So we go through another iteration here, reasoning and action. Our reasoning is I can now provide the answer of keyboard function keys to the user. Okay, great. So then we use the answer tool. It's like final answer in more common tool agent use. And the answer would be keyboard function keys, which we then output to our user. Okay, so that is the React loop. Okay, so looking at this, where are we actually calling an LLM, and in what way are we actually calling an LLM? So we have our reasoning step. Our LLM is generating the text here, right? So LLM is generating, okay, what should I do? Then our LLM is going to generate the input parameters to our action step here. That will, those input parameters and the tool being used will be taken by our code logic, our agent executor logic, and they will be used to execute some code in which we will get an output. That output might be taken directly to our observation, or our LLM might take that output and then generate an observation based on that. It depends on how you've implemented everything. So our LLM could potentially be being used at every single step there. And of course, that will repeat through every iteration. So we have further iterations down here. So you're potentially using LLM multiple times throughout this whole process, which of course, in terms of latency and token costs, it does mean that you're going to be paying more for an agent than you are with just a standard LLM. But that is, of course, expected because you have all of these different things going on. But the idea is that what you can get out of an agent is, of course, much better than what you can get out of an LLM alone. So when we're looking at all of this iterative chain of thought and tool use, all this needs to be controlled by what we call the Agent Executor, okay, which is our code logic, which is hitting our LLM, processing its outputs, and repeating that process until we get to our answer. So breaking that part down, what does it actually look like? It looks kind of like this. So we have our user input, goes into our LLM, okay, and then we move on to the reasoning and action steps. Is the action the answer? If it is the answer, so as we saw here, where is the answer? If the action is the answer, so true, we would just go straight to our outputs. Otherwise, we're going to use our selector tool. Agent Executor is going to handle all this. It's going to execute our tool, and then from that we get our 3 reasoning, action, observation, inputs and outputs, and then we're feeding all of that information back into our LLM, okay? In which case we go back through that loop. So we could be looping for a little while until we get to that final output. Okay, so let's go across to the code. We're going to be going into the Agent Executor notebook. We'll open that up in Colab. And we'll go ahead and just install our prerequisites. Nothing different here, just LangChain, LangSmith optionally as before. Again, optionally, LangChain API key if you do want to use LangSmith. Okay, and then we'll come down to our first section where it's going to define a few quick tools. I'm not necessarily going to go through these because we've already covered them in the agent introduction, but very quickly, LangChain core tools, we're just importing this tool decorator, which transforms each of our functions here into what we would call a structured tool object, this thing here, okay, which we can see. Just having a quick look here. And then if we want to, we can extract all of the sort of key information from that structured tool using these parameters here, or attributes. So name, description, arg schema, model, JSON schema, which give us essentially how the LLM should use our function. Okay, so I'm going to keep pushing through that. Now, very quickly, again, we did cover this in the intro video, so I don't want to necessarily go over it again in too much detail, but our agent executor logic is going to need this part. So we're going to be getting a string from our LLM. We're going to be loading that into a dictionary object, and we're going to be using that to actually execute our tool as we do here using keyword arguments. Okay, like that. Okay, so with the tools out of the way, let's take a look at how we create our agent. So when I say agent here, I'm specifically talking about the part that is generating our reasoning step, then generating which tool and what the input parameters to that tool will be. Then the rest of that is not actually covered by the agent. Okay, the rest of that would be covered by the agent execution logic, which would be taking the tool to be used, the parameters, executing the tool, getting the response, aka the observation, and then iterating through that until the LLM is satisfied and we have enough information to answer a question. So looking at that, our agent will look something like this. It's pretty simple. So we have our input parameters, including the chat history user query. We have our input parameters, including the chat history user query, and actually would also have any intermediate steps that have happened in here as well. We have our prompt template, and then we have our LLM binded with tools. So let's see how all this would look. Starting with, we'll define our prompt template. So it's going to look like this. We have our system message. You're a helpful assistant when answering users' question you should use on tool provided. After using a tool, the tool output will be provided in the scratch pad below, okay, which we're naming here. If you have an answer in the scratch pad, you should not use any more tools and instead answer directly to the user. Okay, so we have that as our system message. We could obviously modify that based on what we're actually doing. Then following our system message, we're going to have our chat history, so any previous interactions between the user and the AI. Then we have our current message from the user, okay, which will be fed into the input field there. And then following this, we have our agent scratchpad or the intermediate thoughts. So this is where things like the LLM deciding, okay, this is what I need to do. This is how I'm going to do it, aka the tool call. And this is the observation. That's where all of that information will be going, right? So each of those you're going to pass in as a message, okay? And the way that will look is that any tool call generation from the LLM, so when the LLM is saying use this tool, please, that will be a system message. And then the responses from our tool, so the observations, they will be returned as tool messages. Great, so we'll run that to define our prompt template. We're going to define our LLM. So we're going to be using GPT-4o Mini with a temperature of 0 because we want less creativity here, particularly when we're doing tool calling. There's just no need for us to use a high temperature here. So we need to enter our OpenAI API key, which we would get from platform openai.com. We enter this, then we're going to continue, and we're just going to add tools to our LLM here, okay? These, and we're going to bind them here. And then we have tool choice any. So tool choice any, we'll see in a moment. I'll go through this a little bit more in a second, but that's going to essentially force a tool call. Now you can also put required, which is actually a bit more, it's a bit clearer, but I'm using any here, so I'll stick with it. So these are our tools. We're going through, we have our inputs into the agent runnable. We have our prompt template, and then that will get fed into our LLM. So let's run that. Now we would invoke the agent part of everything here with this. Okay, so let's see what it outputs. This is important. So I'm asking what is 10%? Obviously that should use the addition tool. And we can actually see that happening. So the agent message content is actually empty here. This is where you'd usually get an answer. But if we go and have a look, we have additional keyword args. In there we have tool calls, and then we have function, arguments. Okay, so we're calling a function. Arguments for that function are this. Okay, so we can see this is string. Again, the way that we would parse that is we do JSON loads, and that becomes a dictionary. And then we can see which function is being called, and it is the add function. And that is all we need in order to actually execute our function or our tool. Okay, we can see there's a lot more detail here. Now, what do we do from here? We're going to map the tool name to the tool function. And then we're just going to execute the tool function with the generated args, i.e. those. I'll also just point out quickly that here we are getting the dictionary directly, which I think is coming from somewhere else in this, which is which is here. Okay, so even that step here where we're parsing this out, we don't necessarily need to do that because I think on the LangChain side they're doing it for us. So we're already getting that. So the JSON loads we don't necessarily need here. Okay, so we're just creating this tool name to function mapping dictionary here. So we're taking the the tool names, and we're just mapping those back to our tool functions. And this is coming from our tools list. So that tools list that we defined here. Okay. And we can even just see quickly that will include everything, or each of the tools we define there. Okay. That's all it is. Now we're going to execute using our name to tool mapping. Okay, so this here will get us the function. So we'll get us this function. And then to that function, we're going to pass the arguments that we generated. Okay. Let's see what it looks like. All right, so the response, so the observation is 20. Now, we are going to feed that back into our LLM using the tool message. And we're actually going to put a little bit of text around this to make it a little bit nicer. We don't necessarily need to do this, to be completely honest. We could just return the answer directly. I don't even think there would really be any difference. So we could do either. In some cases, that could be very useful. In other cases, like here, it doesn't really make too much difference, particularly because we have this tool call ID. And what this tool call ID is doing is it's being used by OpenAI. It's being read by the LLM so that the LLM knows that the response we got here is actually mapped back to the tool execution that it's identified here. Because you see that we have this ID, right? We have an ID here. The LLM is going to see the ID. It's going to see the ID that we pass back in here, and it's going to see those two are connected. So you can see, okay, this is the tool I called, and this is the response I got from it. Because of that, you don't necessarily need to say which tool you used here. What you can, it depends on what you're doing. Okay, so what do we get here? We have, okay, just running everything again. We've added our tool call. So that's the original AI message that includes, okay, use the add tool. And then we have the tool execution tool message, which is the observation. We map those to the agent scratchpad. And then what do we get? We have an AI message, but the content is empty again, which is interesting because we said to our LLM up here, if you have an answer to in the scratchpad, you should not use any more tools and instead answer directly to the user. So why is our LLM not answering? Well, the reason for that is down here, we specified tool choice equals any, which again is the same as tool choice required, which is telling the LLM that it cannot actually answer directly. It has to use a tool. And I usually do this, right? I would usually put tool choice equals any or required, and force the LLM to use a tool every single time. So then the question is, if it has to use a tool every time, how does it answer our user? Well, we'll see in a moment. First, I just want to show you the two options essentially that we have. The second is what I would usually use, but let's start with the first. So the first option is that we set tool choice equal to auto. And this tells the LLM that it can either use a tool or it can answer the user directly using the final answer or using that content field. So if we run that, like we're specifying tool choice as auto, we run that, let's invoke. Okay. Initially you see, wait, there's still no content. That's because we didn't add anything into the agent scratchpad here. There's no information, right? It's all empty. Actually, it's empty because, so here you have the chat history, that's empty. We didn't specify the agent scratchpad. And the reason that we can do that is because we're using, if you look here, we're using get. So essentially it's saying, try and get agent scratchpad from this dictionary, but if it hasn't been provided, we're just going to give an empty list. So that's why we don't need to specify it here. But that means that, okay, the agent doesn't actually know anything here. It hasn't used a tool yet. So we're going to just go through our iteration again, right? So we're going to get our tool output. We're going to use that to create the tool message. And then we're going to add our tool call from the AI and the observation. We're going to pass those to the agent scratchpad. And this time we'll see, we run that. Okay, now we get the content. Okay, so now it's not calling. You see here, there's no tool call or anything going on. we just get content. So this is a standard way of doing or building a tool calling agent. The other option, which I mentioned, this is what I would usually go with. So number 2 here, I would usually create a final answer tool. So why would we even do that? Why would we create a final answer tool rather than just, this method is actually perfectly, it works. So why would we not just use this? There are a few reasons. The main ones are that with option 2, where we're forcing tool calling, this removes the possibility of an agent using that content field directly. And the reason I found this good when building agents in the past is that occasionally when you do want to use a tool, it's actually going to go with the content field. And it can get quite annoying and use the content field quite frequently when you actually do want it to be using one of the tools. And this is particularly noticeable with smaller models. With bigger models, it's not as common, although it does still happen. Now, the second thing that I quite like about using a tool as your final answer is that you can enforce a structured output in your answers. So this is something we saw in, I think, the first LangChain example, where we were using the structured output tool of LangChain. And what that actually is, the structured outputs feature of LangChain, it's actually just a tool call, right? So it's forcing a tool call from your LLM. It's just abstracted away so you don't realize that that's what it's doing, but that is what it's doing. So I find that structured outputs are very useful, particularly when you have a lot of code around your agent. So when that output needs to go downstream into some logic, that can be very useful because you have a reliable output format that is going to be output. And it's also incredibly useful if you have multiple outputs or multiple fields that you need to generate for. So those can be very useful. Now, to implement this, so to implement option 2, we need to create a final answer tool. As with our other tools, we're actually going to provide a description, and you can or you cannot do this. So you can also just return none and actually just use the generated action as essentially what you're going to send out of your agent execution logic. Or you can actually just execute the tool and just pass that information directly through. Perhaps in some cases, you might have some additional post-processing for your final answer. Maybe you do some checks to make sure it hasn't said anything weird. You could add that in this tool here. But yeah, in this case, we're just going to pass those through directly. So let's run this. We've added, where are we? Final answer. We've added the final answer tool to our named tool mapping. So our agent can now use it. We redefine our agent, setting tool choice to any because we're forcing the tool choice here. And let's go with what is 10 plus 10. See what happens. Okay, we get this, right? We can also, nice thing here is that we don't need to check, is our output in the content field or is it in the tool calls field? We know it's going to be in the tool calls field because we're forcing that tool use, which is quite nice. So, okay, we know we're using the add tool and these are the arguments. Great. We go through that process again. We're going to create our tool message and then we're going to add those messages into our scratchpad or intermediate steps. And then we can see again, okay, content field is empty. That is expected. We're forcing tool users. No way that this can be or have anything inside it. But then if we come down here to our tool calls, nice. Final answer, args, answer, 10 plus 10 equals 20. All right. We also have this, tools used. Where is tools used coming from? Okay, well, I mentioned before that you can add additional things or outputs when you're using this tool use for your final answer. So if you just come up here to here, you can see that I asked the LLM to use that tools use field, which I defined here. So list of strings, use this to tell me what tools you used in your answer, right? So I'm getting the normal answer, but I'm also getting this information as well, which is kind of nice. So that's where that is coming from. See that? Okay. So we have our actual answer here, and then we just have some additional information. Okay. And we've also defined a type here. It's just a list of strings, which is really nice. It's giving us a lot of control over what we're outputting, which is perfect. That's, when you're building with agents, the biggest problem in most cases is control of your LLM. So here we're getting a honestly pretty unbelievable amount of control over what our LLM is going to be doing, which is perfect for when you're building in the real world. So this is everything that we need. This is our answer. And we would, of course, be passing that downstream into whatever logic our AI application would be using. Okay, so maybe that goes directly to a front end and we're displaying this as our answer, and we're maybe providing some information about, okay, where did this answer come from? Or maybe there's some additional steps downstream where we're actually doing some more processing or transformations. But yeah, we have that. That's great. Now, everything we've just done here, we've been executing everything one by one, and that's to help us understand what process we go through when we're building an agent executor. But we're not going to want to do that all the time, are we? Most of the time, we probably want to abstract all this away, and that's what we're going to do now. So we're going to build essentially everything we've just taken. We're going to take that and abstract it away into a custom agent executor class. So let's have a quick look at what we're doing here. Although it's literally just what we just did. Okay, so custom agent executor. We initialize it. We set this max iterations. I'll talk about this in a moment. We initialize it. That is going to set our chat history to just being empty. Okay, good. So it's a new agent, and there should be no chat history in this case. Then we actually define our agent, right? So that part of the logic that is going to be taking our inputs and generating what to do next, aka what tool call to do. Okay, and we set everything as attributes of our class. And then we're going to define an invoke method. This invoke method is going to take an input, which is just a string, so it's going to be our message from the user. And what it's going to do is it's going to iterate through essentially everything we just did, okay, until we hit the final answer tool. Okay, so, well, what does that mean? We have our tool call, right, which is, we're just invoking our agent, right? So it's going to generate what tool to use and what parameters should go into that. Okay, and that's an AI message. So we would append that to our agent scratchpad, and then we're going to use the information from our tool call, so the name of the tool and the args and also the ID. We're going to use all of that information to execute our tool and then provide the observation back to our LLM. Okay, so we execute our tool here. We then format the tool output into a tool message. See here that I'm just using the output directly. I'm not adding that additional information there. We do need to always pass in the tool call ID so that our LLM knows which output is mapped to which tool. I didn't mention this before in this video at least, but that's important when we have multiple tool calls happening in parallel, because that can happen. When we have multiple tool calls happening in parallel, let's say we have 10 tool calls, all those responses might come back at different times. So then the order of those can get messed up. So we wouldn't necessarily always see that it's a AI message beginning a tool call followed by the answer to that tool call. Instead, it might be AI message followed by like 10 different tool call responses. So you need to have those IDs in there. Okay, so then we pass our tool output back to our agent scratchpad or intermediate steps. I'm sending a print in here so that we can see what's happening whilst everything is running. Then we increment this count number. We'll talk about that in a moment. So coming past that, we say, okay, if the tool name here is final answer, that means we should stop. Okay. So once we get to final answer, that means we can actually extract our final answer from the final tool call. Okay. And in this case, I'm going to say that we're going to extract the answer from the tool call or the observation. We're going to extract the answer that was generated. We're going to pass that into our chat history. So we're going to have our user message. This is the one the user came up with, followed by our answer, which is just the natural answer field. And that's going to be an AI message. But then we're actually going to be including all of the information. So this is the answer, natural language answer, and also the tools used output. We're going to be feeding all of that out to some downstream process as preferred. So we have that. Now, one thing that can happen if we're not careful is that our agent executor may run many times. And particularly if we've done something wrong in our logic as we're building these things, it can happen that maybe we've not connected the observation back up into our agent executor logic. And in that case, what we might see is our agent executor runs again and again and again. And I mean, that's fine. We're going to stop it. But if we don't realize straight away, and we're doing a lot of LLM calls, that can get quite expensive quite quickly. So what we can do is we can set a limit, right? So that's what we've done up here with this max iterations. We said, okay, if we go past 3 max iterations by default, I'm going to say stop. All right, so that's why we have the count here. While count is less than the max iterations, we're going to keep going. Once we hit the number of max iterations, we stop. Okay, so the while loop will just stop looping. Okay, so it just protects us in case of that. And it also potentially maybe at some point your agent might be doing too much to answer a question. So this will force it to stop and just provide an answer. Although if that does happen, I just realized there's a bit of a fault in the logic here. If that does happen, we wouldn't necessarily have the answer here, right? So we would probably want to handle that nicely. But in this scenario, it's a very simple use case. We're not going to see that happening. So we initialize our custom agent executor, and then we invoke it. Okay, and let's see what happens. All right, there we go. So that just wrapped everything into a single invoke. So everything is handled for us. We could say, okay, what is 10? We can modify that and say 7.4, for example. And that will go through, we'll use the multiply tool instead, and then we'll come back to the final answer again. Okay, so we can see that with this custom agent executor, we've built an agent, and we have a lot more control over everything that is going on in here. One thing that we would probably need to add in this scenario is, right now I'm assuming that only one tool call will happen at once. And it's also why I'm asking here, I'm not asking a complicated question, because I don't want it to go and try and execute multiple tool calls at once, which can happen. So let's just try this. Okay, so this was actually completely fine. So this did just execute it one after the other. So you can see that when asking this more complicated question, it first did the exponentiate tool, followed by the add tool. And then it actually gave us our final answer, which is cool. Also told us it used both of those tools, which it did. But one thing that we should just be aware of is that from OpenAI can actually execute multiple tool calls in parallel. So by specifying that we're just using this 0 here, we're actually assuming that we're only ever going to be calling one tool at any one time, which is not always going to be the case. So you would probably need to add a little bit of extra logic there in case of scenarios if you're building an agent that is likely to be running parallel tool calls. But yeah, you can see here actually it's completely fine. So it's running one after the other. Okay, so with that, we've built our agent executor. I know there's a lot to that. And of course, you can just use the very abstract agent executor in LangChain, but I think it's very good to understand what is actually going on to build our own agent executor in this case. And it sets you up nicely for building more complicated or use case specific agent logic as well. So that is it for this chapter.